So we're gonna continue on this one, and this is the something I really didn't know. I know, and I believe this is so important. Sorry guys, this is so important. We all going to answer one of the most fundamental questions about COVID-19. And I guarantee you one thing, you will get it. And we're gonna use genetics. Maybe you don't think you are, you don't know about genetics, but you will see. We'll see how this simple but powerful information can solve a lot of things. I didn't know. Honest to God, I did not know. But together we'll do it. And at the end, your job will be just one job to do and you will see how important it is, okay? And let's just look at the board. So what I find out after I've done how it's called, that first part of what to learn about COVID-19, after I did the first one, this idea show up. And believe me, this is so important. And please, we have to do it together. And what happened is I didn't know. So we don't have to go further. I'm gonna give it to you right away. We know. I always gonna use something we know. Let's say you have police, let's see the police. You have a crime that happened 30 years ago. 30 years ago, right? They never know who did it. And what police do, we all know. They go back, they do a genetic analysis, right? And they're gonna say we found a match, right? That when they did the DNA test on the crime scene, they say they found a match. Now they have a genetic profile for the guy who did it because he was there, right? But question will be, when we use this same a match or DNA proof that you was there, what does that really mean? After 30 years, the DNA they find on site, and the DNA you have, DNA are the same. We see that all the time, right? What that tell us? That tell us time has no effect on genetics. What that really mean? A newborn baby, let's say a newborn baby, DNA will not change until he died. We know that, right? But we don't. Basically, that tell us the guy who did this crime 30 years ago, let's say he's now 60, we're gonna find the same DNA. Even if he's 90, it's the same DNA. If you go 30 years back, it will be the same. So time has no effect on genetics. And the issue we have during COVID-19 and what mistake we always made is, that's it, a virus and human. In a human eye, right, we can say a lot of newborn baby, a toddler, infant, we have all the vocabulary. The virus doesn't see that. Virus doesn't, in the molecule, because he's talking molecular, he doesn't see that. Okay? He doesn't see that. We human, we see toddler, we see male, female, virus cannot see that. Okay? So if DNA, so basically what I want to say, in a molecular level, there is no difference between a baby and an adult. Right? No difference. Right? And we already prove it here. You did that crime 30 years after, they check it's the same DNA, right? The baby, even before he born, we can take the DNA, test it to a father. And it will say it matches you as a father or not, right? Okay? So if there is no difference between a baby and an adult in a genetic level, and another argument we can use, a baby DNA is the mother DNA plus the father DNA. So even if it's a babe, a newborn, his genetic is the genetic of the two adults. There's no difference. Okay? And you will see. You will see. Now, when we're talking about, this is where you're going to get it. A mask and distance. We're talking about air contamination, right? So think about it. Now, if air contamination is, right? If air contamination, that's what he was using. If an adult and a baby are exposed in the same environment where a virus is circulating, there is no way a virus gonna differentiate between adult and baby. In other words, right? There is no distinction between adult and a baby because we all breathing same air in the environment. And during my first video, I used a perfume, right? And I didn't even know about this idea. I was just explaining how, using a perfume, if everybody's breathing same air, there shouldn't be any difference between a baby and an adult. Okay? What does that tell us? So, air contamination cannot be. Before I say that, let's see. We know that adult was being adult and babies. We know that children or babies was less infected than adult. In an environment where, let's say, a couple with a baby in a stroller, and another baby like 4 years walking, when this couple, right, go to an environment where a virus is being spread for all of them, if air is the only agent, they all be exposed the same way because the virus cannot distinguish between an adult and a baby. Okay? So basically, the genetic tell us if it was just air contamination, adult and children, there shouldn't be any differences because there is no reason. And remember, a virus also is a DNA or RNA. This DNA or RNA gonna talk to the DNA or RNA of a DNA of the human, right? So basically, he gonna go on the nucleus. So basically, during COVID-19, When we talk about contamination, it's a DNA or RNA of a virus attacking the DNA of human, right? In the nucleus, right? So you remember I was not interested in the inside of the human. I was talking about the outside. Outside. And this is inside. But when you talk about nucleus, it's the inside of inside. Intracellular, right? So all those who worked on vaccine gonna go in the inside, like the blood circulation, right? Outside is everything I was trying to explain on my previous video. The DNA being in the human here, it's the inside of the inside. I'm still don't want to talk about anything about immunology because this is about vaccines. So if the virus gonna attack this part, the only thing can be between gonna be this one. But now, knowing that a baby DNA and an adult DNA are the same because DNA does not change with time. DNA is not affected by, I didn't know that. So if it's not affected this time, so when the virus is gonna attack, it doesn't even see because we can see a baby DNA is half is from the mom and another half is from the father. So therefore, if we give back, we do, let's say the virus is in this room, you have an adult and children, they all gonna be exposed in the same way. But during COVID-19, that's not what we were seeing. Okay? During COVID-19, we were seeing typically children less affected, and normally if it was air, so if density of a population is higher, you're gonna have more contamination. More contamination, right? So if air was the main vector, adult and children, there will be no differences. And any population are bigger in number, we're gonna have more infection. And air being the vector, it has to be random contamination. We didn't see a random contamination. We were seeing a pattern showing us, let's say here in Canada, some group was more infected than others. Children less infected than others. So you have at least 3 types, especially in the big cities. So that's not random. So that tells us we cannot air contamination or wearing a mask and cannot be the way the virus was being distributed. Just using the genetics. And that tells us everything, because even if you look what the WHO predicted is based on the fact that the air, right? Let's say if you have a factory that giving us a bad smell or contamination, everybody are going to be infected at the same level, and more you are close to the center of that infection, you're going to be. So the infection going to be random. But here, like I said, we are part of what was going on. We know that children was not affected the same way adult. So therefore, air cannot be the vector. And this is at least a very bad and a very good information. Bad because why we were not able to figure it out very early. Okay? Why we cannot know that air cannot be the main vector? Because of the data we were seeing. But it's a good news the moment we know, okay, we cannot go fix the past, right? But we can know next time we will ask how the virus is circulating. And we are sure that not wearing a mask and social distancing, because we already see that cannot be with the data. Basically, the virus was having free pass. That's what I want to say. The virus was having free pass. Why we was thinking we are protecting, we was not protecting. Because wearing a mask and social distancing was not effectively happening, or was far from being the main way the how it's called, the virus is being moved, just by using the genetics, telling us there is no difference between an adult and a newborn. Genetically, there is no difference. And we know that when you have the fecundation, that's where the human genome is set. When the two spermatozoid and ovocyte met, that when it's set. Very early. Or even the first step, okay? So that cannot be. Air contamination cannot be. And genetics tell us no. The moment we see a pattern between people, air cannot be the main vector. And I believe that's the mistake we made. Because, and how are we going to do that now? That's where you guys have a question. So this is now where you guys will have to ask, or we all gonna have to ask one question. We showed, right, that if we just consider air being where the virus circulates and people getting there shouldn't be any difference between adult and children. And if you have bigger population, you should have more contamination. And you remember we checked between Oman, Yemen, and UAE. Oman was 31 million, right? Oman was 31 million. He has 0.03%. No, sorry, Yemen has 31 million. He has 0.03% of infected. Oman, 5 million, we have 7 point something infection. And UAE has 10.6. I was making the mistake. It was 10 million. So this show us, right, that air cannot be, because you have 3 countries, and the one who has the biggest number, let's say more dense population, has 200 or 300 times less infection. That's also another proof. Okay? So basically, the modeling we put on our front to fight was based solely or mainly on air being the way the virus is gonna move between people. And all the data and all the observation we made tell us no. And the DNA just fix it. Because we're having a virus that is a DNA or RNA moving, going to affect the human DNA, okay? Because the specificity of a molecular activity or DNA doing using specific enzyme to do replication or coding protein, it's very specific. So the virus DNA gonna get into our body, gonna go through the immunological defense system, the blood, the circulatory system, and the lymphatic system, and gonna go directly to the inside the cell and attack our DNA, change the normal molecular process to his own process. That virus cannot distinguish between a man and a woman, an adult or a non, or even a black, a white, or a yellow. He cannot do that. But the moment we see this how it's called, because we need to know if, let's say, air was not the way virus was being, like I said, it's the most amazing thing. It's the most amazing finding we can have, because we already know we make that mistake. And the prediction they're gonna have, WHO will be, everybody gonna be exposed the same way. When you have more people gonna be more contaminated, and that's why they thought Africa will be devastated, right? Because of air. But the reality is it cannot be air. So that changes everything. Science tells us, right? With everything we said, we use science. We use from, how it's called, from in the beginning of my first video where I explained even using the word virus was a mistake. So we use biology itself, we use science to explain that air cannot be, right, the main way the vector was moving. And we explain that human ecology, human biology, and human beings the carrier of the virus, and our standing position, and not knowing how the virus can be compared to an animal because of our standing position. All the thing we have put is based on science. So now the other question is going to be, what was the science to explain we have to wear a mask and do social, because you cannot have science in two ways. Science will tell us here is the way. If this DNA tell us it's not the way, this one, air cannot be the way. So question you guys will have to ask is, and it's the only thing you're going to do, what was the science that tell us we have to wear a mask and do social distancing? What was the science? That's the only question you're going to ask. And I think from that point now, everything's going to be easy. And I think this is so important. Very simple, but we know DNA. It's a yes or no, right? It's not something we can play with, okay? And I believe from this information and what we did, because this doesn't tell us how the virus moves, the other part will tell us all the dynamic, and I think I've done everything to show you. And you have two fundamental scientific aspects that tell us no, wearing a mask, social distancing should not be the front thing we have to do. And now let's think about it. We will able normally now, without any hesitation, to say we make this mistake, we'll fix it. And I try to show you the number of people who was infected with the virus, and it's just crazy. It's crazy. We have 7,000, let's do it, 700 millions, right? 705 millions. How many people die? And how many people have the vaccine? Maybe a couple billion at least. And we have all this issue. So all the video I'm doing is based on, how we can avoid this one. Okay? And don't make the mistake saying air is zero possibility. No, air can be a very tiny percentage where COVID-19 was being spread. And you remember when we did when we did this on this on Yemen, Oman, and UAE. I have done as a country and look at the percentage. You see, just I wanted to see. You see, Chad very close to them. Same that with Senegal. You see, they all have very similar percentage of infection. Okay, but you can see the UAE had way more infection than other countries, because simply of what was going on in the habitat. Okay, so I think this is gonna be, I think it's good enough now, and your only job gonna be, please, your job now is to spread this one, to share the video. I don't do sharing because I'm just doing it because I believe it can help. So the only thing I'm asking for you is to share it and do the other part, asking WHO or whoever decide to wear a mask, what was the science? Very simple question. What was the science you used to wear a mask? Thank you, and I believe it's going to be the last thing I will do, and I hope you guys will do the part of your job, and we will be in the future, maybe we'll be having less issue with viruses. Thank you. See, we have how many people was infected.